Good to be here. My days in data science go back to AltaVista, in fact. I was working on AltaVista as on the system side, but my role was what we used to call back then a spanner, which meant I kind of understood enough about what was happening on what at the time we called the relevant science side to be able to feed the requirements into the systems building half of what we did in a fairly first-hand fashion. But I was never a relevant scientist. I wasn't a data scientist. I just understood enough to be able to translate requirements. And that's significant because I think, especially at search engines where the infrastructure is so large, there's a lot of the systems folks just kind of get lost kind of in the weeds of what they're doing in terms of building systems. And they forget the fact that those systems are built for the sake of running very complex algorithms. So I've been at the big data and the data science space from the system side for many years. And in getting into AltaVista, it was an interesting experience for me because I got a PhD in computer science expecting to go into research and doing stuff like operating systems, programming languages. When we worked on the web search engine, we were having an immediate impact on the world in a way that we never really anticipated, right? As a researcher, like, hey, 10-year time horizon, improving programming languages is very different from building a search engine where people can now do first-hand research, for example, into their medical condition, which really kind of changed, the access to information from around the world. So it was a very kind of satisfying opportunity, right, to have that kind of direct impact on what was happening, doing what we love to do, which is build large, complex systems. So, I went from AltaVista, actually created a little startup company, got acquired into Yahoo. At Yahoo, I played the same role initially in the search team. So I was the chief architect of the search and advertising team. Helped foster the use and the investment into Hadoop there at Yahoo. Eventually became the CTO of Yahoo, kind of bringing Hadoop with me and making it the standard platform for data science at Yahoo. So I've had that experience on the internet side of the world, but as I've kind of stepped a little bit back from being in the internet, what I see is a big opportunity to apply some of the lessons from the world of the internet to many other areas in the world. And I think we'll see in a minute why. But what I wanted to do today, since I'm not a data scientist, is to share a little bit more how I think the data science and big data is going to impact not just the world of the internet, not just web search, but really pretty much every single endeavor that people pursue. And I think it's a very exciting time to be doing data science. And my goal here is perhaps to help people who are more direct practitioners of data science to kind of understand, hey, how can I aim my activities to have the biggest impact? So if you look at the world of data from an IT sense, kind of for most of its life, it's really kind of in most corporations, it's very inward facing, right? You have an ERP system, you have a CRM system, you've got all of these systems that are very internal facing. And you take that data, you put it into Enterprise Data Mart, and you can kind of understand your business pretty well. But I think the most fundamental change that's happening, right? Like the core transition of big data is that the shift from data is going from this very inward-facing approach or look to a very outward-facing approach, where we can now measure what's happening out in the real world, whether it's Internet of Things, kind of measuring what's happening to equipment out in the field. Social media is really a way of measuring the impact and the thoughts and the feelings of literally billions of people. There's all kinds of interesting third-party data sets out there, which, for example, give you access to the weather or even to transaction data of your competitors, interestingly enough. So you're now able to get data about what's happening outside your firewall versus the olden days where it's mostly about what's happening inside the firewall. And once you can measure, once you measure something, you can really create strong feedback-driven processes to optimize it. And I think that really is at the heart of the big data revolution. And I think the net of it is that, we're all going to become internet companies. I mean, internet companies, cyberspace was instrumented from the very beginning. So they had kind of an early start on this ability to kind of instrument immediately what is the impact of my actions having on my users, on my market. As the rest of the real world is getting instrumented, every company is going to have the opportunity to behave like an internet company. Now, that does not necessarily mean that they're all going to have foosball tables. That's not what it means to be an internet company. What I think it means to be an internet company is moving from kind of a feedback cycle that's more measured in quarters and sometimes even just based on a yearly planning cycle. And that planning cycle is being driven ultimately by kind of these massive roll-ups delivered in the form of PowerPoint presentations to a tiny few number of people in the company who look at that quote-unquote feedback and decide, okay, here's what we're going to do next year. I mean, that's what the feedback loop of most corporations look like today. I think what makes an internet company special is, again, that ability to measure in real time what's happening in their universe and to build business processes that close that loop at all time scales. That includes kind of an automated instantaneous feedback cycle, which is a lot of fun. But if you dig a little bit deeper, what you see is the ability to have these nested feedback loops where there's that instantaneous feedback loop, there's more of an intraday, an intra-week, a monthly, a quarterly, and it's all driven off of real data. And I'll go through an example of that a little bit later. Oops, I hit the wrong button. But what I want to do is to talk a little bit about how does that translate, into the way we think about the systems that we build, and we think about, if you will, the galactic architecture of corporate IT, because again, my role in life is more on the system side. And so what I have here is kind of a 100,000-foot view of what pretty much every large internet company looks like, where they have what we call the on-stage, right? That's where the consumers come to do their search, do their mail, read their news, and so forth. And that on-stage experience throws off what some people call the digital exhaust, right? All of your clicks, all of your user-generated content, your transactions, and so forth. And that all gets collected into what I'm calling here a content supercomputer. And then that gets combined with additional third-party sources of data that come in. And it gets crunched essentially into models. And then those models go up into, in the case of Yahoo, for example, a content and an ad-serving system that was optimized around various objective functions that we would tweak through the years. And that's kind of the core. Now, what I've shown here as well is something that I call the backstage. And I think that this is less understood and is critically important to having that feedback-driven business models. And what happens backstage is that's where people go to first and foremost understand what's happening on stage, right? When you have 1 billion users, understanding what's happening itself is quite complicated. So there's a lot of so-called analytics that happens there. But ultimately, understanding isn't enough. You want to understand for the sake of affecting change. And so in those backstage applications is where you would go to tweak the knobs, submit your ads, submit content, and ultimately try to influence what's happening on stage as well. Now, in the early days of the internet, for example, at Yahoo, the backstage systems were quite primitive, right? It wasn't that long ago where an ad campaign at Yahoo was implemented by somebody going in and manually putting an ad tag into an HTML page. Well, that's probably been a long time. But nonetheless, that was the beginning of the backstage. And through the years, the backstage systems grew up in a pretty haphazard way. It wasn't until sponsored search came along where I think those of us at Yahoo realized, wow, those backstage systems are really, really, really important to running the business. And we started making a larger investment in them. So those backstage systems are critically important to delivering against these kind of feedback loops that we're talking about. Now, as I was indicated earlier, as the rest of the world gets instrumented as deeply as cyberspace has been implemented, you can see, hey, you just put some trucks and cars and buildings and printers, on the onstage. It's not that much different. Basically, my Fitbit, essentially has an Apache log in it someplace, right? That's going up to the cloud somewhere. Fundamentally, it isn't that different. And I think this 50,000-foot architecture of how do you build your IT systems, around the ability to measure in real time is not going to change. So I think the lessons we learned in the world of the internet will translate over in many ways fairly directly. So that's an architecture. And I want to kind of dig down one layer deeper in terms of technologies, because I think we hear all these technologies. There's Spark, there's NoSQL, there's Hadoop. How do they fit into this? There's the old-fashioned stuff of transactional databases and of various kinds, SQL or NoSQL. So the on-stage applications themselves include their own primary storage. But then you've got kind of the data collection, and streaming is part of that. And I've kind of put, that gets a little complicated, so I put more hours in. But the fact of the matter is you want to have these direct cut-throughs of data to support low latency. And so that's how those kind of fit into this picture. So search and scoring, I think will play an increasingly important role in the future. I think people here at H2O World are probably also a bit more advanced than most in terms of actually using real-time scoring and an online aspect of machine learning to do things. But that's where the rubber hits the road, right? That's where your models can make a big difference. And when you're doing this at large scale, right, if you've got 1 billion users, those systems themselves are quite complicated and interesting. And my experience, again, in the world of the internet, there's actually quite a few custom systems are built there to maintain kind of a price performance that makes sense. Expanding a little bit on that middle layer, of course, the core there is kind of your storage and batch processing. So HDFS and HBase are important. The Hive meta store, I think, is becoming an increasingly important place where metadata is kept in the world of Hadoop. MapReduce, Spark, and Hive, of course, are commonly used tools there. And then you have the interactive analytics. And I think there's an enormous amount of innovation still happening here, because here you kind of want to have your cake and eat it too, right? You want petabytes of data available at a millisecond, right? And obviously that's a tough trade-off. And so there's a lot of different solutions out there which try to hit different points in that trade-off space. And also there's different types of analysts who want to get at this data, right? You've got data engineers, you've got more business analysts, you've got data scientists, and they all have their own kind of favorite way of interacting with data. So, in all of that, though, I put down at the bottom there to point out that that's primarily in service of that Backstage experience. That's where the modeling's done. Once the models are in place, they get put into that kind of tree, if you will, into those serving systems. So I've shown two different pictures of, hey, what does the future look like in this world of big data? And I did want to relate them, right? On the left-hand side, we have more of the business view. On the right-hand side, we have more of the architecture view. And I think you can put those loops directly on that architecture view. So that innermost fully automated loop, is completely happens between the onstage, and that middle computing tier. But then what I find interesting is what I call the figure 8, which supports all those other timescales, where let's see if the pointer works. It's not going to work. But anyways, you can kind of see how that traces a figure 8, where data gets collected on stage, it goes into that middle layer, it gets made available through the Backstage experiences for people, again, to understand and ultimately influence what's happening on stage. Their models, for example, get pushed back out, through that serving tier. And you kind of have a feedback loop that goes through that. And I will say, again, kind of some of the historical experience at Yahoo, in that early, more ad hoc approach to building up the company, there was a lot of kind of one-off connections between an on-stage experience and its dedicated Backstage experience. And I think one of the things that Hadoop allowed us to do over time, because we had kind of a central Hadoop service, is bring all the data from all the experiences into one place and really start to decouple a little bit the specifics, the specific on-stage experiences and the tools that we had to understand what was happening there. And I think that decoupling actually was quite useful. So anyways, that's, again, on the left-hand side, I think from the perspective of, big data practitioners who want to make a difference in your company and your industry, I think what you should look for is opportunities to use, this newly available roughly real-time data, to start to build feedback loops, and through feedback drive, more optimal delivery and outcomes. And then on the right-hand side, we have, again, a kind of a 50,000-foot architectural view of how can you build data systems that allow an iterative approach to doing that. So I want to go from here, kind of the what of big data and how it's going to impact things, to some more specifics in terms of, okay, great, I have that infrastructure in place, but what do I actually do as a practitioner? And so here again, in that metaphor of the internet company, right? The fundamental tool of internet companies that a lot of people in a lot of other industries are very jealous of is A/B testing. Oh, they get to do A/B testing and we can't. I'm a car manufacturer. How do I do A/B testing when I have to ship a car? There's this kind of envy of A/B testing out there, and rightfully so, right? I mean, that's how you create experiments and actually take advantage of the fact that you can have feedback. But let's kind of generalize a little bit, away from A/B testing and more, A/B testing is a form of experimentation. And I think that's kind of the key tool that's available to everybody, is thinking in terms of experiments. Now, I put up here on this slide kind of a progression that I see in a lot of papers on big data, data insight action. And I've never really liked this, and the way that I've experienced this is you've got some serfs, in IT who need to get, data together, and then they deliver it to the priests who are the data scientists who go and do a bunch of stuff. But then ultimately, the data scientists generate PowerPoints that then go to royalty. Those are the executives, and that's the action side of it, right? And so that's kind of how it works. And by the time you go from the data to the action, so many assumptions and so much speculation has been put into this that even though people say, oh, look, we're being data driven, in fact, not really. And so the way that I think is a much more helpful way to look at it is you form a hypothesis. You run experiments, right, to falsify or verify the hypothesis. And then, as we'll talk about in a bit, I think this process leads then very naturally to implementation. And I think it turns out that this is a way also to really enable kind of bottom-up change in organizations. Now, I think a really, really important element here is that the hypothesis has to be, action-oriented. If I make this change, then this business outcome will happen, right? If I change the color to blue, we'll get more clicks. I don't know. It can't simply be, observations about correlations. Those observations about correlations might be useful to help formulate action-oriented hypotheses. But in my view, the key to A/B testing, right, the key to experimentation in general in this setting of how do we use real-world feedback to drive more optimized business results is in formulating hypotheses that have an action kind of at their core and then trying to test them. And we'll leave that off. Now, what I wanted to do is to go through an example from, again, my experience at Yahoo, not so much on the search side, where we did an awful lot of what I was just talking about, but on the front page side, where relatively late in the life of Yahoo, it turns out that the front page of Yahoo was completely manually programmed, meaning everything up there was decided in great specificity by the editorial team. And the project that I'm talking about here was focused on the stories that would show up there. And like other parts of the front page, that was Those were hand-selected articles, and they were laid out in a specific order determined by a team of human editors. The search team comes in and says, oh, we don't need those stupid editors, we can replace them with algorithms, right? There was this kind of initial chauvinism, machine chauvinism that came in here where, hey, we're going to get rid of the editors. Because look, we had, an enormous amount of training data, right? I mean, we had billions of page views. People clicked or didn't click on articles. I mean, you couldn't ask for more training data, and it seemed like, hey, this is a simple thing to automate. And so a project was started to try to get better results. So that led to the first hypothesis. We can generate better results replacing people. And this was no small project at Yahoo. It wasn't a lot of people, but there was a lot of dollars at stake. And as you can kind of tell, there was also a lot of culture at stake, where what up to that time were kind of two different parts of the company, the search side, and the media side, started interacting on a fairly high-stakes project. So that led to round one, right? And it turns out that we had a fair bit of experimental infrastructure already in place for the front page. As you can imagine, a lot of A/B testing infrastructure, among other things. And so we were fairly able, to support a lot of experimentation around this. And it turns out that at least using the features that we had, which is just the content really of the page plus some features about the user, we couldn't generalize it, right? We really couldn't, decide, what story coming, what breaking news really gets clicked and what doesn't. So that initial just replace people altogether hypothesis got falsified. That's a good thing in science, right? I mean, there's supposed to be a prejudice to falsifying hypotheses. But along the way, it turned out what was discovered is that once you put a story out there, and everything's obvious in hindsight, once you put the story out there, you can actually fairly quickly figure out if people are going to like it, right? The click rate of a sample of your audience, is highly predictive of the click rate of your entire audience. And so that led to an approach where instead of having the editors kind of manually program, the articles completely, they would pick kind of a candidate list. Here's some articles we think are interesting. And then the algorithms would kick in and say, oh, let me see, right? And they'd throw them up there, and this is, of course, a great place for reinforcement learning, right? So you'd throw the articles out there, and they'd get clicked on, or they wouldn't get clicked on. And the editors themselves started to become scientists, right? They started to experiment with different stories and see where it went. And those results were encouraging, and once that kind of started turning over, we then got into the kind of the continuous improvement process where this was kind of a macro hypothesis that completely changed how we operated. Once this was put in place, there was a lot of incremental improvements that could be done. For example, it turns out you could segment your user base, right? And you can start to look at the click-through rates of different articles by different user segments. And that turned out to be very, very powerful. The editors themselves started to learn a little bit better and become better at picking candidates because they were running experiments all the time now, and they got real-time feedback. And they started to get better as well. So that breakthrough in round two actually really kind of unleashed a big change. So I wanted to dig just one level deeper into how do you do this. And the idea here is to really be agile. So again, another thing I don't like about the data insight action is it's very waterfall-y. And so here we have a more agile approach, right? And so the key is, you formulate a hypothesis that does imply an action. And actually in this step one, it turns out the data insight action kind of mantra actually does make a lot of sense. This is where it does make a sense. But the point is you don't stop there and bring it up to the executive team and argue, okay, we should do this. That's just the hypothesis. And after that's formed, you truly become data-driven. And you do that by running experiments. And the key thing here is you have a ladder of experiments where lower on the ladder, they're cheaper, but less conclusive. And then higher on the ladder, they're more expensive, but more conclusive. And if you think about A/B testing, the fact of the matter is that that's a fairly expensive way to test an idea, right? You have to, like if there's an algorithm you want to change, you actually have to implement the algorithm at close to production quality to go to A/B testing. And so, for example, in search, on the web search side, we had a ton of experiments that we could run kind of offline of increasing complexity, but of better confidence values. And so the last thing we would do is do A/B testing. And there, it was not about relevance. At that point, we pretty much knew that the change was going to improve relevance. But it turns out in web search, there's a lot of secondary effects, right? Make relevance better, monetization goes down, that's a problem. And so A/B testing was really to try to catch these secondary effects. And in the interest of time, I'll go a little bit faster. Access to data, especially for companies that are new at this, is typically the blocker. And then making sure that the lab and real life agree. A lot of times what would happen if they don't agree is you got this great algorithm that works great in the lab, you put it in production, and you don't see the improvements. And so kind of getting fidelity there is important. The Backstage is critical, building out those tools. This is the content optimization. Along the top, you see the different segments that I was talking about. Along the rows are the different articles that were selected, and you can kind of see where you provide feedback to the editors in terms of what's performing well in which segment. And then, obstacles, if you want to drive change in your organization, to this is, first and foremost, it's resistance to change and assumptions, right, that different cultures in the company have. And I think that, actually is probably the biggest blocker to making big change. And then as I indicated, obtaining data, having adequate infrastructure, and then having the right talent, those are other big obstacles. So I think I can see the countdown here. So do we have a little bit of time for questions?
We have a lot of questions, but if Raymie, you could be around, I'm sure a bunch of people want to ask you questions outside. So Raymie will stay on for a bit, I suppose, and that way we can finish questions. Thank you.
Okay, thank you.
Warm round of applause, please.